Hello everyone, this is Richard Eaton, your CTEC 134 Database Administration instructor. This video is a continuation of a video series that I started creating last week that deals with something called functional dependence and a subject called normalization. The video on functional dependence is essential to understand in order to move on to properly understand normalization. I created a PowerPoint presentation for talking points for that last video, and I've also done one for talking points for this video. And that PowerPoint presentation is in Canvas modules along with this video. You don't have to have the PowerPoint presentation open on your local computer because I have it open on my computer, and I'll be essentially walking you through that PowerPoint. So let's get going here. I think one thing I've mentioned in prior videos is that beginners in relational database design make a lot of mistakes. And what's unfortunate is sometimes they make those mistakes after they've already invested dozens or maybe even hundreds of hours into their design and entering data. And then when they find out that their design has issues or so many issues, they're not really willing to give up all that time they spent. And so they just deal with the issues as best they can. So it's really important to learn properly functional dependence and the first three normalization rules. So we've done functional dependence. My goal here is to start talking about normalization rules. There really are considered 5 normalization rules, 5 rules that one should follow in designing a database. But only the first 3 we'll be talking about today. The 4th and 5th normalization rules are a bit arcane, obscure, and I think most database designers pretty much don't pay any attention to those, and they focus only on the very first 3. And so that's just fine for this class. When we look at the rules, we start with the very first rule, what's called first normal form. That's what on an N, 1NF stands for, first normal form. And we don't move on to the second normal form until we've resolved the first normal form issues. And then we look to see if we have second normal form issues. And if we do, we resolve those before we move on to third normal form. So in other words, you do them in order. The first normal form rule says a relation is in first normal form if it does not contain any repeating groups. By the way, if you hear something in the background, it's my dog eating a bone here, and I hope it's not going to be too disrupting, because I kind of like having him in here in my office with me. Anyway, repeating groups. In other words, every attribute or field or column, same name for an attribute, must contain one unit of data. Another way of saying that is all fields should be atomic, meaning that the data can't be divided any further. Another way of saying that is a table shouldn't contain more than one column that represents the same type of non-distinct data. Now that last one there is probably not clear to you, but we'll see examples of that here in a minute. Here's an example of an orders form. And it's logical that if a customer orders something, they're going to have oftentimes more than one item on their order. And we need to know how to deal with that in our database. And in this case right here, this particular table has a situation where a particular order has more than one item on it. 51610, this order here, has a KL78 and a TR40. And it has number ordered 25 and 10. And logically, you would say that, well, 25 must be associated with the KL78 because they're on the same row. And 10 must be associated with TR40 because they're on the same row. But in a relational database cannot make that assumption. And so this is a significant problem. So what we have here is more than one value in a single field. And that is a normalization rule. We have to deal with that. Here's another one down here where there are 3 items on this particular order. And so how do we deal with that? Here's another example of how one might decide that would be a solution. They could say, well, let's do this. For this order number 10, let's make an item number column and a number ordered column and a quoted price column. And let's put them all and if they have multiple items, we'll put them all in the same line with a comma separating them. So look at for order 12 here, we have 2 items, a CD33 and a DW23 with a comma separating them, and a 3,5 representing the number ordered, and a 10,15 representing the quoted price. Actually, let me back up here again to this one. In this particular scenario, in order for us to put in a 25 and a 10 in this column, we have to make it a character data because we can't write a numeric data with a 25 and then a new line and a 10. The database just won't do it. So we might say, well, what about this technique right here? Well, could I put in a 3,5? Well, no, you can't do that because that is not valid numeric data. And this is not valid numeric data. So the database system would reject you trying to do that. So this technique is just as deficient as the prior one. So then you might say, well, here's a solution. Let's do it this way. Let's say that we have an order number, an order date, a customer number, and we have an item num1 and a number ordered 1 and a quoted price 1. And then we have item 2, number ordered 2, quoted price 2, and so on. Doing it this way, we could say, look at this second line here. This particular customer ordered a CD33 and they ordered 3 of them. Number ordered 1 is 3 and quoted price 1 is 10. In this case, this 3 could be defined as a numeric value and it's single value. There's a single value here in this particular column. And same was true with the quoted price. It's a valid number and it's a single value here. So then we move on to the second thing they have ordered, a DW23, and we have a valid number here for number ordered 2 and a valid number here for quoted price 2. And then the last line has 3 items on it. So really, that's just another way of representing a repeating group. Because what would happen if we had an order that had 5 items on it? This table wouldn't work. We would have to reconstruct this table to add a item number 4, number ordered 4, quoted price 4, item number 5, quoted price 5, number ordered 5, etc. So this is still a repeating group problem. The solution is to essentially duplicate some of this data. Here's an example. 51610 had 2 items on it. And so what we did in this solution is we said order number 5610, here's the date, it's a KL78 and they ordered 25. And then we said on the next line down, order number 5610, that matches this one. This date matches this one, and we have a TR40 and they ordered 10. That certainly is an improvement over what we had before, although there's still some issues here and some redundancy going on in duplicating the order number and the order date. But that basically is a normalized table. We'll see a better solution when we get into the second and third normal forms. But this is a table that is in first normal form. Second normal form has redundancy issues, and it has what's called update anomalies. We have problems when we try to update some data. We have inconsistency potentially in the data. We have problems when we try to add data, and we have problems when we try to delete data. One of the problems I mentioned was redundancy. In this case here, we have, here we go. We have order number 5610, order number 5610, that's redundant data. Down here, we have 51623, 51623, 51623, all with the same dates. That's redundant data. Another thing that we see here, in this particular order, 51614 is a rocking horse. And on a different order down here, this is a different one, different order, 51619 also is a rocking horse. But we have redundant data there, and that really presents some problems. One of the problems is that if we have maybe hundreds of orders in a given day, or people have ordered a rocking horse, we might type in rocking horse in one case, maybe a red rocking horse in another case, maybe a rocking horse, and we mistyped something and we misspelled one of these words. So the rocking horse in this case might not match the exactly rocking horse in this case. And that seems, well, that's pretty easy to type rocking horse. But imagine you have thousands of records and maybe even a 1,000 orders in a given day for a particular item. Let's say that item is this one down here. It's Zauber Katzen brain teaser. I can't even say it. But can you imagine if you have dozens of order takers typing in this value into a table? What's the likelihood that they're all going to type it in exactly the same way? And then what would happen if your boss comes to you and says, you're the database administrator, we're changing the name Zauber Katzen brain teaser to just brain teaser or something else. And you would have to find every occurrence, whether it was spelled correctly or incorrectly, and write some kind of an update query to update all those occurrences. So that's a problem. Another problem is if we were going to add a new product. What if we were going to add a brand new product that we haven't added? So what do? Well, do we add it to this table? Do we come in here and put a new item number here? There's a new row, and then add the new description for that product. If we did that, we would have to leave the order number blank and the order date blank, the number ordered, and the ordered price is blank. So that presents a problem. And what would happen if we ended up saying we want to delete this record here, this woodblock set? And it's the only record that has a woodblock set on it. And we don't. This is not ordered anyplace else. It's just here. We still have a valid woodblock set to sell, but we deleted this particular order. Now we had no reference to a woodblock set anyplace. So we have all kinds of problems with this particular structure: redundancy problems, update problems, inconsistency problems, additions and delete problems. A relation is in second normal form if it is already in first normal form and no non-key attribute is dependent on only a portion of the primary key. No non-key attribute is dependent on only a portion of the primary key. Another way of saying that is all non-key attributes are functionally dependent on the entire primary key. In other words, a non-key column must depend on the whole key, not just a portion of it. This particular problem can only happen when you have a compound primary key. If you don't have a compound primary key, then you would not have a second normal form violation. You couldn't have a second normal form violation. So you could move on to looking at third normal form violations. But in our TAL database, we certainly do have a compound primary key in our order line table. So we really do have to understand what that's all about. As I said earlier, a second normal form condition, we must have a compound primary key. And if we don't, we can't have a second normal form violation. This is the actual solution here for a second normal form, and it looks a bit complicated. And I think what I'm going to do is end this video here at second normal form violation, because it's getting, I think, to be a bit long. And I will continue the discussion with second normal form violation and third normal form violation in a part 3 video. So for now, let's just say goodbye, and then we'll go finish this discussion in a part 3.